I have developed various vision algorithms over my 5-decade career. Probably the most notable is what is usually referred to as the Kanade optical flow algorithm. When objects move in a scene or you move your own camera, points in the image appear to move or flow. It's called an optical flow. Computing the optical flow precisely and quickly is fundamental requirement for any video or motion image analysis. One example of its use is video coding. We know that today video is efficiently coded from original source to MPEG and other video coding method. The basis of that coding is understand which points in the current image move to the next image, which point in the next image. Once we understand that, then we don't need to send all the color or video information. Instead, simply send motion only. And that's the basis of video coding. And my optical flow algorithms is used for basically any motion image data compression algorithms. The most important application of my work in robotics perception is probably navigation capability, such as autonomous driving of cars or autonomous helicopter. My team has developed a system that incorporates vision, not only using the color and such cameras that are two-dimensional, but also three-dimensional camera that captures the three-dimensional information directly. It's usually called LiDAR. When we started our autonomous driving back in early 1980s, the capability of vision was relatively undeveloped. Yet we could use at that time one of the very rare LiDARs available, and showed that the use of LiDAR is very effective. Three-dimensional vision, LiDAR vision, is very effective in understanding the scene and location of the obstacles in order to safely drive a car. When the word virtual reality, VR, was coined back in the 90s, people worked on mostly creating artificial world by computer graphics and other techniques. I thought it would be more interesting to start with the reality. In other words, we actually model or input reality into the computer, so that becomes a virtual reality. So in order to emphasize that aspect, that is the starting reality, rather than artificially creating reality, I coined the word virtualized reality. In other words, the reality that was virtualized. And today's terminology, maybe it is the same concept of virtual twin, that is the computerized model of a certain reality. So anyway, by using many cameras, in other words, in order to create the virtualized reality, in order to create the model, complete three-dimensional, or not only the shape but also appearance model of the reality, you need to observe the scene by not just by one camera, but many cameras. So I started working on using multiple, not just several, but tens or 50s or even hundreds of cameras placed in a room or environment, so that the video that were captured by all of those cameras processed and create moving reality, model of the reality. So I call it 4D modeling, not just the 3D modeling, but also motion modeling. So anyway, such an idea can have some interesting applications. For example, creating the record of important events such as surgery or other events, so that other people later can visit and observe and enjoy the same event. And one very popular, turns out, application of the idea was to use many cameras to create a replay of a great play in a sporting event. The first of that type is called iVision, that was used 2001 American football Super Bowl. The whole stadium had 33 cameras on the upper deck of the stadium looking into the field, and whatever beautiful play occurred, then the broadcaster can create a replay of that by spinning around the major player of that play by using a large number of robotic camera. And today, actually, as one can see, such a spinning replay in sporting events is used in almost any sports, as we can see in today's daily lives, as well as big events such as Olympic Games. Looking into the future, I foresee a couple of exciting applications of visual plus robotic capabilities. One is helping people, older people, and people with disability to live independently. I call such technologies in general quality of life technologies. To human, I believe that the best quality of life is to be able to do as much as possible independently what you need to live your daily lives. And I think advanced vision-based, as well as, of course, other capabilities, robotic functions, can be the key for such quality of life technologies. And another area that I'm looking at is in more advanced state of virtualized reality. So if you think of a big event such as the, say, Expo, which is going to happen in Osaka, effectively the visitors as well as the site cameras have a large, gigantic, many camera, create a gigantic many camera, large number of camera system in a ad hoc manner. So if we can coordinate such video, then the people in the world can actually virtually and freely access to the various data, not just the source data, but also the process to create the better quality of data, as well as the removal, taking care of the privacy. People actually can access those information or data freely. I call it hop on, hop off, because people can hop on to any place, any location, and then if they get tired, wants to go another place, hop off from that, and then hop on to another source. Recently, I hate to see things like fake face as the wrong use of advanced AI and computer vision technologies for wrong purposes. And indeed, I might be somewhat responsible in fake face, because I remember that 2009 or 2010-ish, we created a video which we named Obama Speaks Japanese. The video, actually, I moved my face and spoke Japanese, and then that image was processed and mapped to the face of President Obama as if he speaks just like I was speaking. And we thought, well, it was fun in a sense. But actually, the capability was intended for a serious and, I thought, a meaningful applications. For example, what we were thinking of is one, to understand how a human facial expression or head movement, in other words, how when you turn or nods, or whether or when you turn or nods your head, or close eyes, or delay your response in human-to-human communication. What is the effect of that? And by understanding that, we thought that we can help people who have the difficulty in smoothly communicating with each other. And also, we thought that such capabilities will help people who do not want to their own face in communicating with others. In today's concept, the avatar, for use of avatar for Zoom and other video conferences. So the goal was a genuine purpose, but when we look back, certainly that is the kind of technology, the region technologies, which today we worry about fake face and other false information for wrong purpose. So from technologist's point of view, I'm pretty sure that we should be able to create the way to certify the data that is genuine versus non-genuine, and so that just like a copyright, the watermarking the video, so that the video or the synthesized data for wrong purposes by wrong people can be detected. So in any way, it's a sad and too bad some technology has some potential wrong use purpose.